So in my today's video, I'm going to explain to you all the first small part of the preparation of haloalkane by free radical method, and then after that I will explain the preparation of aryl halides. Okay, so here preparation of haloalkanes from alkanes by free radical method. Now, what is that here? See, free radical method means a free radical is produced and then added. So, free radical method. Now, see, suppose say you have compound which is say methane. If you treat this with chlorine in the presence of UV, ultraviolet rays, UV, or say heat, then what happens? Every hydrogen of this alkane, methane is alkane, is replaced by halogen. So you will get CH3Cl plus HCl. Now this free radical thing that in the 11th standard you have learned, so please go to that. Now this methyl chloride, this is methyl chloride. Methyl chloride will continue to give you further with chlorine, and you will get here what is called as methylene chloride. You can call it as dichloromethane, CH2Cl. One more hydrogen from here will be removed and that replaced by chlorine. So you get here methylene chloride plus HCl. Then methylene chloride, like this it will continue till you get carbon tetrachloride. So here with chlorine you will light. Okay, then you will get here chloroform. This is chloroform plus HCl. Of course, you all should know chloroform. Alright. And then chloroform reacting with more of chlorine, you will get here same way in the UV light. Okay, you will get here CCl4 tetrachloromethane plus HCl. So this reaction takes place by free radical method. So I will just recollect that free radical method means what? Suppose say chlorine. This is treated with UV light. This break up to give you a free radical like this. Chlorine with one electron. There are two electrons between the chlorine and chlorine bond. So one bond means remember two electrons. One bond. Chlorine and chlorine joined by a bond. That's why it is Cl2. So that bond is consisting of how many electrons? Two electrons. So one electron goes to one chlorine, another electron goes to another chlorine. So you will get the free radical, and that free radical then continue reacting with this methane and form CH3 or free radical, CH3 with dot and then HCl like that. So that's why that is called free radical method. Suppose say the compound is propane. Suppose compound is propane, say, or butane or propanaldehyde treated with chlorine in the presence of UV light. Okay, UV. Now in this case, you will get the free radical here like this, CH3, CH2 dot. Dot means electron. And this will break up to give you what? Cl dot. That Cl dot and CH3 dot will form a bond, and therefore you will get a compound like this, CH3, CH2, CH2Cl. Plus, there is also formation of another compound where chlorine can go over here, and therefore you can get here CH3, CHCl with CH3. Now this is called 1 chloropropane, 1 chloropropane, and the other one is called 2 chloropropane. Alright. Now here, remember that when you get a mixture, okay, difficult to separate, but they can be separated by based upon their boiling point. Fractional distillation it is called. Now this is secondary. Secondary is more stable. Therefore this is the major product. What I said here followed, and this is minor. So here this compound is 1-chloro will be minor and 2-chloro is what? Major. Remember that this what you get here in this case will be like this. I'll show you so that you can know for neat and all. CS3, CS2, CS2 with a dot. Okay, with a dot. Free radical will be produced as intermediate. And this is called primary free radical, primary. And the other one will be free radical that you will get will be CS3, CH dot with CS3. This is secondary free radical. Okay, so here free radical secondary free radical is more stable than primary free radical. I hope you understood what is that free radical. Now chlorine, see, will be here 2 electrons. Okay, and in the presence of EV, this will break up. I showed there. So it will break up as giving Cl dot plus Cl dot. Alright. Now this Cl dot will combine here and form CS3, CS2, CS2 dot. And that is Hi from here will combine with Cl dot and form HCl. So this is one product and this is another one. So these two will be formed. Of these two, this is primary free radical, this is secondary free radical. Primary free radical is less stable than secondary, and therefore this become the minor product. Primary free radical will be less stable, whereas secondary is more stable, therefore that become the major. So here in this case, therefore you get this compound is major. So please remember for neat and all. Okay, suppose say it was like this: CS3, CS2, CS2, CS3, N-butane. Then in that case, secondary butyl chloride, that will be more stable, and therefore that is major. I hope you followed. Okay, primary will be less stable, secondary will be more stable. In such cases, when there are more than 2 carbon, 3 carbon, 4 carbon, like that it goes on, then you will get not a single compound, but you will get the mixture. Okay, and that mixture of these two mixture, the one which is secondary will be more stable than primary, and tertiary will be still more stable. I hope you followed here. It's methane plus chlorine, methyl chloride or chloromethane. This is what here, chloromethane plus more of chlorine. This gives you CS2, Cl2, which is called as methylene chloride or dichloromethane. Dichloromethane. After that, it will that dichloromethane reacting with, if you want, I can write here. Dichloromethane, that is called IUPAC name, dichloromethane. Chloromethane. Okay, and this dichloromethane reacting with more chlorine form chloroform. I hope you followed. See, one more hydrogen will be removed. What will go there? In place of that hydrogen, chlorine will go, and therefore it becomes CH. When one hydrogen is removed from here, what left there? CH. And more chlorine entering here, that becomes Cl3. That is how it goes on. Then that chloroform will react with more of chlorine. So again, this hydrogen will be removed by chlorine, and therefore it will become carbon tetrachloride. That is called as tetrachloromethane. IUPAC name will be what here? Tetrachloromethane. Now, of course, this is not the haloalkane only. One, you see, as I told you, monohalogen derivative called alkyl halide. This is alkyl halide. This is what halogen derivative of alkane. Remember, which has got 2 chlorine here, which has got 3 chlorine here, tetra, 4 chlorine, etc. Okay. So, next video, I am going to explain preparation of haloarine.